This is the RunSafe Security Minute. We're here to provide 1-minute security briefs. Today's question is,
Shane, how can you capture a complete understanding of all of your dependencies and compiled code to inform your security posture?
It's a great question, Alex. So there's three primary approaches that people take when trying to understand their dependencies in their compiled code. And when we say compiled code here, we're really talking about C, C++. Yes, there's a lot of other languages out there that are compiled, such as Rust and Golang, but those tend to have good package managers. And so, you can just generate an SBOM from those Rust and Golang projects and, not have this problem. But in the C, C++ space, we don't really have a good package management solution that's universally accepted. Yes, the Conan package manager from the JFrog folks is functional and works, but not a lot of projects are using it, especially not in the kind of open source space. So that's growing though, but right now it's really not widely adopted. And so we have to look at different approaches for getting that dependency information. And so there's three primary approaches. Two are pretty standard, and one is really unique to RunSafe, and that's why we've got a product offering there. So the first approach is just looking post-compilation at the binary that was produced and building a dependency information based off of that. And so that's going to get you things like libopenssl or glibc as dependencies, and whatever is in their dependency trees as well. But the challenge here is that you're not going to see those static archives that come in, or header files, or source files that potentially got modified. And so if we look at that, you're going to be missing things in those dependency lists and that software bill of materials. So the second approach that people take is they go all the way to the left. And when they go all the way to the left, they're looking at the source repository and doing analysis there. And that can be a little harder to automate, but it does have some challenges there in that you might target different versions of libraries based on the release that you're putting out or the operating system that you're targeting. And so, you're not going to know necessarily that for this product that I shipped today, version 3.2, what were the actual dependencies that went in if you just look at the source code. And that gets even more complex when you look at pulling in things from the internet, like from, Artifactory. You may have like a trusted repository store, and you may just be pulling down the latest version. Well, if you just look at the source code, you can't know what the latest version is from that artifact store. Or you've got something like Yocto, where you've got software coming down from some random server on the internet, and that may have different version information, different files, etc., based on what's actually shipping that day. So the third approach is the one that RunSafe is pioneering, and one that we've got a really great offering on, which is to build that software bill of materials at compile time. So we're going to catch every single source file, every single object file, every archive, everything that's provided by the compiler, the linker, anything that goes into that built code, built binary, gets caught by our software bill of materials. And the cool thing about that is it also excludes any software, any source code, any object files that aren't needed as part of that build process. So you're not going to get more information, more dependencies that aren't actually dependencies, and you're not going to get missing dependencies either. So you get that, kind of perfect, complete set of information for anything that goes into that application or library that you're building.